So in this next video, we're going to talk a little bit about the course structure along with the learning objectives and how we will be addressing those and our schedule. So probably a pretty interesting video to everyone. So here are the learning outcomes of the course. And one thing I wanted to say is we can't modify these, particularly at two-year colleges. These are all agreed upon by both all two-year colleges in the state along with the four-year colleges in the state. And they're what allows this class to be transferable to other institutions. So we don't have a flexibility of what content we have some flexibility in the content we cover and the assessments that we utilize, but I have to at the end of the semester be able to go back to my boss, the dean, and say, here is the content that I taught and the assessments that I used in order to make students make sure that students could do these 6 outcomes. So if you look at these outcomes, and I know many of you, when you come into a programming course, again, going back to what I said in the last video, think that you're going to be developing apps or something like that. But really in an engineering programming course, you're interested in learning the automation and computation techniques that are useful for engineering programming applications, which I spoke of in the actual last video. So not surprising that this is what the actual learning outcomes look like given that fact. So 1, being able to use matrix and array operations for equation solving. That might look boring, but really what that is about is if you think back to that first video where I talked about working on that computational electromagnetic simulator to actually do antenna design, the majority of engineering problems. So here's how the world works very, very quickly. All of the physics that you're learning or will be learning, you'll notice that the physical laws are governed by differential equations. However, those differential equations are very hard to solve in anything other than trivial cases. So the approach for solving them in the real world always breaks down to using numerical methods to transition the differential equations into a system of linear equations. The system of linear equations is incredibly large, though, and that process of doing so can be automated in different simulation tools that are based upon numerical methods like finite element analysis or FEA, or integral methods or something like that. So at the end of the day, actually understanding simulating how a structure works, whatever it may be, whether it's actual fluid dynamics or computational electromagnetics or strength of materials or structural analysis, it all boils down to solving a big system of linear equations. And if you remember, a system of linear equations is a matrix times a vector equal to a vector. So all of the math that governs real engineering is about being able to use matrices and array operations in equation solving. 2, identifying the strengths and weaknesses of the conventional programming languages. Here is the big idea with this. Programming languages can basically be defined on a continuous line. And that line, the way that they're differentiated is how much you need to understand about the actual computer architecture in order to program in that particular language. So if you need to know a lot about the nitty-gritty details of how the microcontroller works or the microprocessor works, that's called a low-level programming language. The lowest level of the programming languages is assembly language, where you're communicating to the microprocessor in the native language that it understands. As you kind of move away from the level of responsibility that you have to understand how the actual microprocessor works, you're moving towards what's called a higher level programming language. So for an example of that, many of you are familiar with a language like Python. When you actually look at Python code, even if you've never seen Python before, you can probably walk through and guess what each line is doing, because the language or the rules of language, which are called the syntax, actually look like the way that we speak. It's more similar to how a human speaks than how a computer speaks. So those high-level languages, they're more powerful in the sense that since they're closer to things that we can understand, we can do more with them. But naturally, as you move more away from the language the computer understands, which actually does the work, to the level that you understand, that translation process of going down to the actual hardware introduces a lot of bloat. So it's never going to be as efficient. So that's basically the trade-off in the conventional, all the programming languages that exist. We'll give you some experience in scripting languages like MATLAB and Python, which are actually interpreted. And we'll also talk about compiled languages as well, a little bit like C++. 3, using spreadsheets and the built-in features to basically do any type of quantitative or qualitative methodologies. As we'll see in the schedule, we'll have a lab associated with that. 4, describing methods for the design of programs that control equipment or analyze data. We're going to have a discussion board assignment related to National Instruments LabVIEW software, which will show you how that actually works in the real world for those of you that want to go that route. 5, writing computer programs to solve engineering problems and perform engineering simulations using common software tools. We'll use predominantly MATLAB for that, along with a little bit of kind of web-based compilers or web-based interpreters and compilers for Python and C++. And 6, graphically presenting engineering data, results, and conclusions conclusions. Again, the ultimate goal of this is to have kind of a useful outcome that we can use to convey to our stakeholders, whether it's management or the customer. And they are humans, and humans, the majority of our brains are wired to consume information in a visual form. So visualizations are really important. In terms of the course schedule, we're doing lecture 0 this week. The only deliverable is the discussion board 1, or the course introduction. I want you to also make sure that you have MATLAB set up. The second lecture, which I'll post on Friday, will be the introduction to computing for engineers. In week 2, we'll move to an intro to MATLAB lecture. Hopefully everyone will have it set up by then. Remember, you're not actually installing it. All you need is the cloud-based access to MATLAB. Lecture 3 will kind of go over the basics of what computer programming is. We'll talk about data types, variables, and so on. We will have a lab that week where we introduce the concepts of matrices and vectors in MATLAB that will let us hit the course learning objective 1. So your score on that, you might know you have an eLumen portfolio whenever you take a class here. I'm going to go in and say you met learning objective 1, either exceptionally, you just met it, or you didn't meet it based upon how you do on lab 1. In week 3, we'll have lecture 4, intro to data visualization. We'll do 2 labs that week, an intro to computer programming lab and an intro to data visualization using spreadsheets. Remember, spreadsheets was an SLO, so that's the lab I'll use to check SLO 3. We'll have a discussion board in week 3, again, just making sure that everyone is on track with the course. Week 4, we'll have exam 1 review. We'll do an intro to data science lecture. We'll do an intro to data visualization using MATLAB, which I'll use for SLO 6, and we'll have our first exam. And in week 5 through week 8, notice that the second exam will be in week 7. You will have a final coding project, and I won't read through all these to insult your intelligence, but that's how the actual course will be laid out. So you already know that this is an online asynchronous course, meaning I am not going to ask you to do anything at a specific time other than make sure all your assignments are turned in by Sunday at midnight. One thing I wanted to say is that I'm going to roll out course lectures twice a week, generally Wednesday and Friday. I know that I'm late for this week, and the reason is to encourage you to engage with the content multiple times. I'll try to never make anything due that I haven't at least covered a week in advance. So it's going to be tough with only being on an 8-week schedule, but we will do our best. I'm going to change this to fixed office hours. I was debating whether I wanted to do Monday or Wednesday. I'm going to do Wednesday from noon to 1 via Zoom, but I basically live here. So here at SAC, and also I'm at UTSA on Wednesday evenings. So I can meet you in person if we need to work out a time, but just please remember, I really want to meet you and I really want to work with you. But if it feels like it's really tough to get a hold of me, it is a really busy semester. So in terms of the grading, the way that we will grade, if you go back through that schedule, you'll notice we have 6 labs. They'll each be worth 5% of your grade for 30% total. We'll have 4 discussion boards, each worth 2.5% of your grade, or 10% total of your grade. Those are going to be easy things that you don't want to miss. I hate when people end up on the threshold of a grade and they just didn't do a discussion board that takes 15 minutes. So I really want to help you out, but it's really, really tough if someone says, hey, I have an 88, can I have an A? And then they just skip the discussion board that everyone gets full credit on that takes 10 minutes to do. So please be sure that try your best to get everything done, but prioritize your time in such a manner that you get the easy points within the course. We will have 2 exams. Each will be worth 20%. So that'll make up 40% of your grade. And the final coding project, which is going to allow you to work in an end-to-end fashion, like I talked about in the last video, will be worth 20% as well. So in this last lecture, we'll just talk about what the initial steps are to kind of get going on the course here in week 1.